Okay, so for that last problem, we want to make sure that the degree on each term of the homogeneous differential equation must be the same. So again, notice here the degree on that term is degree 2, degree 2, degree 2, and that is kind of an indication that we can apply this homogeneous substitution. Okay, so this one here, we're just going to use a slightly different substitution. So we're going to use v equals y minus x. So when we can use this substitution, or in this case, we're just going to differentiate the v. dv is equal to dy minus dx. Okay, so then we can do our substitution. So the dy is equal to dv plus dx. And that's all over dx. So we'll do the substitution on that side. On this side, we end up with v plus 2. Okay, because we're going to group that, and we're going to group that. And we end up with v plus 1. Okay, so v plus 2 over v plus 1. So separating this out, we get dv plus dx. Okay, we're going to multiply that with v. I think we need to multiply with this v plus 1 to get rid of to be able to get rid of some factors here and combine like terms. So we're going to end up with v plus 2 times dx. Okay, so multiplying this out, I get v dv plus v dx plus, what's that going to be? dv plus dx. Okay, so then I'm just going to put all the dx terms on this side. Okay, so this is going to end up with v plus 1 dv on this side. On the other side, I have v plus 1, so I'm going to end up with the v's cancel out, so I'm just going to end up with 1 dx. Okay, so then I've separated my variables now. I can integrate both sides, so I get log v plus 1 is equal to x plus c. So then this becomes v, do the substitution back, so y over x plus 1 is equal to x plus c. So e to the x plus c, I'm going to turn that plus c into k in the front, is equal to y over x plus 1. Okay, so this becomes e to the k e to the x minus 1 is equal to y over x. And so then finally we solve for y. Y is equal to x k e to the x minus 1. Okay, so there is my differential equation. I was able to do the substitution. Now I use a unique substitution here. This is not the regular substitution, but this is this idea that we can kind of do these types of substitutions allows us to generate these terms and then allow us to sub in for the dy, which then allows us to solve a form of this differential equation that is now separable.